Welcome, fellow explorers, to a journey into the heart of the universe, a journey into quantum physics. What is this enigmatic realm we're about to traverse, you might wonder? Well, quantum physics is a branch of science that deals with the smallest particles in the universe, those at the atomic and subatomic level. It's a world that plays by its own rules, rules that are vastly different from the classical physics we're accustomed to. In this quantum realm, particles can be in two places at once thanks to a phenomenon known as superposition. They can also influence each other instantaneously over vast distances, a concept known as entanglement. These principles and more make quantum physics a mind-bending field, challenging our traditional understanding of reality. So are you ready to dive into this fascinating world and explore its uncanny theories? Fasten your seatbelts as we venture into the world of quantum physics, a world that is stranger than fiction. Imagine a cat that's both dead and alive until you look. Welcome to quantum superposition. This is the curious case of Schrödinger's cat, a thought experiment that introduces us to the fascinating concept of quantum superposition. In the everyday world we're accustomed to, objects exist in definite states. An apple, for instance, can't be both ripe and unripe at the same time. However, in the quantum realm, particles can exist in multiple states simultaneously. This is what we call quantum superposition. Take Schrödinger's imaginary cat, placed in a sealed box with a radioactive atom that might decay, triggering a mechanism that releases deadly poison. According to quantum mechanics, the atom is both decayed and not decayed at the same time, meaning the cat is both dead and alive. This seems impossible, right? But here's the twist. It's only when we open the box to observe the superposition collapses into one of the possible definite states. Until then, the cat remains in a superposition of being both alive and dead. This principle challenges our traditional understanding of reality, pushing the boundaries of what we perceive as possible. It's a concept that defies our classical intuition, suggesting that reality isn't set until it's measured. Now, you might be wondering, does this mean everything exists in a superposition until we observe it? Well, quantum superposition is generally limited to the microscopic world, but it's these very principles that allow technologies like quantum computers to exist, where bits of information can be both 0 and 1 at the same time, vastly expanding computational possibilities. In the quantum world, the line between reality and possibility becomes blurred. It's a realm where the bizarre becomes the norm and the impossible becomes possible. In the quantum world, a cat can be both dead and alive. Now, how's that for a mind bender? Now, let's delve into a phenomenon Einstein himself called spooky action at a distance. Welcome to the uncanny world of quantum entanglement, a strange feature of quantum mechanics that Einstein once famously referred to as spooky action at a distance. But what is it really? Imagine a pair of twins separated at birth, one living in London, the other in Sydney. Now imagine that whatever happens to one twin, say he stubs his toe, instantly happens to the other, irrespective of the distance between them. This, in essence, is what quantum entanglement is all about. In the quantum realm, two particles can become entangled, meaning the state of one particle is directly related to the state of the other, no matter how far apart they are. If one particle is spinning up, its entangled partner will be spinning down. Change the spin of one, and the other changes instantaneously. It's as if they are one entity, even when separated by vast distances. Now let's consider the implications of this. For one, it challenges our understanding of space. How can two particles possibly communicate faster than the speed of light? As Einstein's theory of relativity suggests, they shouldn't be able to. Yet experiments have confirmed time and again that entanglement is a real phenomenon. It's as if the entangled particles are thumbing their noses at our classical understanding of physics. Quantum entanglement also has exciting implications for information transfer. Imagine being able to send information instantly across the universe without any time lag. This could revolutionize fields like computing and telecommunications, and is the basis for the emerging technology of quantum computing. So, in the quantum world, particles can be entangled, sharing information instantly across vast distances. The quantum realm is indeed a strange and fascinating place, full of phenomena that challenge our everyday understanding of the world. As we venture deeper into this realm, who knows what other surprises await us? Intrigued much? Ever fantasized about walking through walls? Quantum particles do it all the time. Let's dive into the world of quantum tunneling, a phenomenon that sounds like science fiction but is a reality in the quantum realm. It's an event where particles, like electrons, can pass through barriers they shouldn't typically be able to according to the rules of classical physics. Think of it as a ball rolling up a hill. In our everyday world, if the ball doesn't have enough energy, it won't make it over. But in the quantum world, there's a chance the ball could simply appear on the other side. It's as if it tunneled through the hill. This is quantum tunneling. This isn't just theoretical mumbo-jumbo, though. Quantum tunneling has real-world applications. It's the principle behind scanning tunneling microscopes, for instance. These devices allow scientists to view the world at the atomic level, offering a peek into the very building blocks of our universe. They work by exploiting the ability of electrons to tunnel through a barrier. Here's how it works. A sharp metal tip is brought very close to the surface to be viewed. A voltage is applied, creating a barrier that the electrons, theoretically, shouldn't be able to cross. But thanks to quantum tunneling, some electrons do make it across. By measuring this current, scientists can form an image of the surface at the atomic scale. Quantum tunneling also plays a crucial role in nuclear fusion, the process that powers the sun and other stars. In this process, protons tunnel their way into each other's territory, overcoming the electrostatic repulsion resulting in the formation of helium and the release of vast amounts of energy. So while we humans can't walk through walls, at least not yet, the tiny particles that make up our world do it routinely. It's just another example of how the quantum world is not only strange and mysterious, but also fundamental to our existence. Quantum tunneling, where particles can pass through barriers, adds another layer of mystery to our quantum tale. Brace yourselves, for we're about to dive into the realm of quantum weirdness. Now, if you thought Schrödinger's cat, quantum entanglement, and quantum tunneling were mind-bending, wait until you hear about the many worlds interpretation. This theory, proposed by physicist Hugh Everett in the mid-20th century, takes the concept of superposition and entanglement and blows it wide open. It suggests that for every possible outcome to every event, there is a separate universe. Picture it like a tree branching out into countless branches, each one a different reality based on the choices we make and the events that occur around us. Imagine flipping a coin. In our everyday reality, it will land either heads or tails. But under the many worlds interpretation, both outcomes occur, each in its own universe. You're now in a universe where the coin landed heads, but there's another version of you out there in a universe where the coin landed tails. It's a concept that's as exciting as it is daunting. It challenges our perception of reality, pushing us to question the nature of existence itself. Are we living in just one of an infinite number of realities? Is every choice we make creating a new universe? The many worlds interpretation is still a topic of hot debate among scientists. While it provides a solution to some of the paradoxes in quantum physics, it also raises a whole new set of questions. As with all things quantum, the many worlds interpretation is a theory that we can't prove or disprove with our current level of understanding and technology, but it's a fascinating idea that illustrates just how strange and wonderful the quantum world can be. So next time you're faced with a decision, remember, in the quantum world, every possible outcome becomes its own universe. Mind-blowing, isn't it? As we approach the end of our journey, let's ponder over the profound mysteries that quantum physics continues to unravel. Our voyage into the quantum realm has been nothing short of extraordinary. We've delved into the perplexing concept of quantum superposition, where a particle can exist in multiple states simultaneously until observed. We've explored the eerie phenomenon of quantum entanglement, where particles, irrespective of distance, seem to be inextricably linked, affecting each other instantaneously. We've also touched upon quantum tunneling, the baffling process that allows particles to pass through barriers as if they weren't there. But these are just the tip of the iceberg. The quantum realm is teeming with more strange theories and unanswered questions. For instance, the concept of quantum gravity seeks to reconcile quantum mechanics with general relativity. But despite decades of research, we are yet to find a definitive theory. Then there's the question of quantum consciousness, the controversial idea that posits our minds as quantum information processors. Quantum physics is also shedding new light on the nature of time. Is it possible that the future can influence the past? as some interpretations of quantum mechanics suggest? And what about the multiverse? Are there countless other universes out there, each one representing a different outcome of a quantum event? These are just some of the questions that scientists around the world are grappling with. The field of quantum physics is a hotbed of research, with new discoveries and theories emerging frequently. Yet the more we uncover, the more we realize that there's so much we don't know. As we stand at the precipice of the unknown, it's clear that the quantum realm is far more complex and mysterious than we could have ever imagined. It challenges our basic understanding of reality and forces us to reconsider our place in the universe. Quantum physics, a realm of endless possibilities and profound mysteries, beckons us to explore further. Will you heed its call? As we conclude our quantum journey, we leave you with an invitation. An invitation to step into the world of quantum physics, a world where the ordinary rules of reality are suspended and replaced by the extraordinary. This realm where cats can be both alive and dead, particles can exist in two places at once, and objects can tunnel through barriers, is just waiting to be explored. Don't let the complexities deter you. Embrace them. Dive into books, scour scholarly articles, watch documentaries, engage in conversations, ask questions, challenge the status quo. Remember, every great scientific breakthrough started with a question, a curiosity. Quantum physics isn't just for scientists in white lab coats. It's for anyone with an inquisitive mind and a thirst for understanding the universe. It's for you. So accept the invitation. The quantum world is waiting. Unravel its mysteries, and who knows, you might just redefine reality itself.